Welcome back to the tutorial on the use of the virtual observatory of GAIA-CLIM. In this tutorial we'll talk about observational data, where we're looking at in particular reference data from ground-based and in situ measurement networks. Normally we would go to the menu to observation data and then select data selection and management area. And here we can choose the essential climate variable that we're interested in. Might just start with temperature, and then we have the drop down box here where we can select different networks. The number that's given in brackets at the end is the number of observations that we currently have in the database. This again is just the demonstration server. It has very few samples in here. Ingestion already has quite a few more than the ones shown here. But for demonstrating the functionality of the VO, that's quite okay. So at air temperature, we might be looking at some normal Gruan radio zones. Yes, we might be looking at temperature for a start. At a later stage, we will have matching satellite observations, so we would then here select which satellite we would like to compare it to. We could narrow down the time interval. And I'll just pick August 13 for a start. I can either click with the mouse or just type the date, which might be faster. And any time of the day, all observations. And then I send a data request. And so on the 1st of August, there was only one zone that I can select down here. Clicking it, I will then create a graph on this side where currently I can see the air temperature as a vertical profile versus pressure. I can now change the scale here, maybe go to altitude, redraw the graph, and now I get a temperature profile versus altitude from the ground to about 34k altitude. That's where the balloon would normally explode, and that's the end of that radius on profile. We can plot next to it the uncertainty of this temperature measurement, also against altitude, so they're comparable. This of course could be automated, and so the uncertainty in the troposphere is on the order of 0.1, 0.12 Kelvin, and then in the stratosphere it gets poorer, decreasing it to about 0.3 Kelvin. That all makes sense. Up here we also see that there's a Gruan radio zone from Lindenberg near Berlin, and the launch date and the launch time. We could now go and we can say either clear all the fields, then again select maybe something different. We could look at an ozone concentration perhaps, or maybe first of all we might look at again at temperature, but this time from the UK Met Office as a comparison, which was calculated for the same conditions as the radio zone, and then we also pick temperature and just send a data request. And then there's quite a few. We can just pick the same date if we wanted to, and plot it against altitude. Of course, the sonde only went up to about 34k. The model goes up to about 80k, so that's why the profile looks a little bit different. But here it is nonetheless. Theory, we should also be able to show humidity here, but still some glitches in the GUI that we need to fix. We could clear again and maybe now choose an ozone zone, look at an ozone profile. To do that we would choose an NDAC ozone zone. Doesn't really matter what we, we could also choose ozone concentration here, but it doesn't really matter, we can still select it later on. Since we only have one, we just ask for all the data sets that we have. Then we just click on it and it plots here temperature versus pressure, or we could use just plot the ozone concentration versus pressure. and so in the troposphere it's rather low, and then it goes up in the stratosphere. That all makes sense to us. Of course, an ozone zone always has a radio sound, so we do also get the humidity profile with it. Okay, we can now also have a look at the early net aerosol LiDAR, which we haven't done so far, and we could have a look at the extinction coefficient. Just go for all the data sets there are, which is just one, and this is the aerosol LiDAR in Potenza, northern Italy, and we get an extinction coefficient versus altitude, so it's a lower troposphere, so the altitude range makes about sense, and that's the aerosol data as an example. Now we may want to go back and look at brightness temperature, which we could get from a Gluon process radiosonde, that is where we have done forward modeling with RTTOF and converted the radiosonde profile into an equivalent brightness temperature as would be seen from space. So-called Gluon process for working package 4. And of course we want to look at brightness temperature in here, and we might want to just send all of them, and on the 1st of August, we pick the same day as before. We can now have a look at this, and it defaults to plot temperature versus pressure, which is not what we want now. And here is a glitch in the GUI. You would normally want to plot brightness temperature versus channel of the satellite, or the pseudo satellite is seen by the radio sonde, and as you can see, we do not have channel as an option to plot against, but for argument's sake I might just plot it against the humidity, which of course doesn't make any sense, but at least you can see there is brightness temperature data in the database, and we will fix this very shortly, so this looks, as we would expect. And that really concludes a first look at the observational data accessible through the virtual observatory. What would be a very next step, of course, is the collocation with the satellite data, and that you can look then at data side by side and look at the differences between two measurements. Okay, thank you very much.